Hey everybody, this is Mr. Hudson. Hope everybody's doing well. I've missed you. Just going to give you one slide of notes here. This is a piece of information that was not given. We didn't have time to get to it on Thursday. So because of all these snow days, what we're trying to do is, rather than having to make some of these up like past the 5-day limit, we're trying to have what are called blizzard bags, which means you just kind of check in and keep up to date with some of the stuff that you're doing in class. That way we don't have to make these days up at a later time. So these are going to be just, again, finishing up section 7-4, and then when you guys get back, we'll go over some assignments, we'll do some reviewing, and within a couple days we'll be taking a quiz over section 7-3 and 7-4. So what you see here is a lot of information that I wrote down previously, obviously before you were watching. But I'm going to graph this equation, r equals 2 times the quantity of 1 plus the sine of theta. And in order to do that, I have started plotting some of these angles here. So I've got a table of values here. This is representing the angles, theta. Down here is representing the r values. And if you might notice, these are all in radians, and I've started to write all of the angles that are on the unit circle. So I start with 0, then pi over 6, then pi over 4, then pi over 3, and so on. Again, all these angles are going to come from the unit circle, and I'm going to continue this as we go on. Then once I've made one full rotation there with all the angles on the unit circle, I'll be able to plot these points on my graph. So you should have some graph paper from Thursday. If you don't, one thing that you could do is just Google printable online polar graph paper, something like that. Or you can just draw a sketch of your own. Okay? So, and again, obviously a lot of this information is written down. I'm just going to kind of walk you through some of the stuff, so you may need to pause this video from time to time. With the first one, we're letting this angle, theta, be 0. So I'm rewriting this equation, 2 times the quantity of 1 plus the sine of theta. So I have 2 times the quantity of 1 plus the sine of 0, because that's the first angle I'm plugging into there. Well, the sine of 0 is 0. So I have 2 times the quantity of 1 plus 0. And if you do the arithmetic behind that, that gives you 2. So the r value here for 0 is 2. As I move to my next angle, plug in the sine of pi over 6. Okay, so my next angle is pi over 6. So I have 2 times the quantity of 1 plus the sine of pi over 6 is 1/2. Again, refer to your unit circle for that. So if you do the arithmetic behind that, and that would give you 3. So pi over 6, I get 3. Likewise, when I plug in the sine of pi over 4 for my next angle, the sine of pi over 4, I'm going with a decimal here because I'm going to plot these points. So it makes it easier to plot these points if they're in a decimal form rather than the radical form. If I do that, that gives me 3.4. Okay? I didn't mean to draw that. With the next one, I'm plugging in pi over 3. Well, the sine of pi over 3 is 0.9, 0.866 if you want to get specific, but we'll just call it 0.9 because we're plotting these points. So if I multiply 2 times the quantity of 1 plus 0.9, I get 3.8. If I plug in pi over 2, I get the sine of pi over 2 is 1. So I have 2 times the quantity of 1 plus 1 is 4. Then, once I get past that point, when I plug in the sine of 2 pi over 3, these values, this 0.9, starts going back down here. And as I plug the next coordinate in, which would be, let's see, we had 2 pi over 3, so 3 pi over 4. If I plug that into this equation, I would have r equals 2 times the quantity of 1 plus the sine of 3 pi over 4 equals 2 times the quantity of 1 plus the sine of 3 pi over 4 is 0.7. So notice how these values are just going back down. Alright, this would give you 3.4. So I'm going to fill these values in. Here for pi over 4, I had 3.4. At pi over 3, I had 3.8. At pi over 2, was 4. Then this is where it started going back down. This is 3.8. This was 3.4. And then the next one would be 5 pi over 6. Well, that R value would be 3. And then when we get to pi, that R value will be 2. So that's only about half of the values from the unit circle. So what I'm going to do is plot those points on the unit circle, I'm sorry, not on the unit circle, but on the polar graph. So my first coordinate was 0, 2. That means I'm going on this 0 radian angle, and I'm going out 2 units. Okay, now the graph paper that I'm using, this is pi over 2. Right here is pi over 4. Right here would actually be pi over 6, and this would be pi over 3. Now I'm not going to label all the way around there, but that gives us a starting point. At pi over 6, if you look at your chart, at pi over 6, the R value was 3. So I go out to pi over 6, and my R value is 3. 1, 2, 3. At pi over 4, it's 3.4. Okay, so this would be 3.4. Here's 4, so 3.4 would be about right there. At pi over 3, we were at 3.8. And at pi over 2, that would be 4. So I went up 1, 2, 3, 4 units. So far I've got what looks like maybe the beginning of a circle. Okay, we'll see if it's actually going to be that circle. So if I keep working around here, this would be 2 pi over 3. This would be 3 pi over 4. Okay, right here would be 5 pi over 6. And then, of course, here is pi. So 2 pi over 3, that went back down here to 3.8, and just refer to your chart for this. At 3 pi over 4, that was 3.4. At 5 pi over 6, that is 3. And then at pi, we were at 2. So the question is, all right, now what happens with these angles down here? For example, 7 pi over 6, and so on. Okay, there's 7 pi over 6. This would be 5 pi over 4. This would be 4 pi over 3. Okay, 3 pi over 2 here. I'm just going to go ahead and fill these in. Let's see, we're looking at 5 pi over 3. 7 pi over 4. And 11 pi over 6. Are you excited yet? So I'm going to go to 7 pi over 6. Whoop, wrong way. Sorry. I'm going to go to 7 pi over 6 and plug that in for R. So we have R equals 2 times quantity of 1 plus the sine of 7 pi over 6. Okay. So the sine of 7 pi over 6 is negative 1/2. So I have 2 times quantity of 1 minus 1/2. 1 minus a half is a half. 2 times that would be 1. So 7 pi over 6, that value would be 1. My next value, 5 pi over 4. So if I plug that in for R, I have 2 times 1 plus, let's just go ahead and do this, the sine of 5 pi over 4, which is negative 0.7. So 2 times 1 minus 0.7, which is 0.3, so that gives me 0.6. So I get 0.6 there. My next value would be 4 pi over 3. Okay, so I'm going to plug in 4 pi over 3, so I have 2 times the quantity of 1 plus the sine of 4 pi over 3. The sine of 4 pi over 3 is negative 0.9, so I have 2 times 1 minus 0.9, and that would give me 0.2. Okay, finally 3 pi over 2 is here. If I plug that in, I have R equals 2 times quantity 1 plus the sine of 3 pi over 2. So I have 2 times, the sine of 3 pi over 2 is negative 1. So I have 1 minus 1 here, which is 0. So that actually gives me 0. Alright, so let's check that out on the graph. For 7 pi over 6, at this angle right here, the R value was 1. So that's here. So this graph was going up and around, and now it just kind of starts curving in here. At 5 pi over 4, that R value was 0.6. So 5 pi over 4, this was 0.6. The next value was 0.2. And then at 3 pi over 2, that value was in here at 0. Now what's going to happen at this point is, as these angles continue, this same pattern, like what happened up here, is going to form here. At 5 pi over 3, that's going to be, let's see, that'll be right here, is 0.2. At 7 pi over 4, that would be 0.6. And at 11 pi over 6, that would be 1. So what we've got is, this graph, it's what's called a cardioid. It goes about, I'm trying my best to draw this, out like this. That should be much more curved. This is ugly, but if you look in your book there, it's something called a cardioid. That's what it is. And that is the graph of this equation right here. Now one thing you could do is, remember we graphed some of these on our calculators on Thursday. If you go to your graph and plug in that quantity, that 2 times quantity of 1 plus sine of theta, that will give you this graph. Okay? As you can see, these take a little bit of time. Now on Thursday, you were given all of these except 57 and 59. So what I would like for you to do, and what I will be checking when we come back from this whole polar vortex extravaganza, I will be checking everything here. So in addition to what you've already done from page 717, do numbers 57 and 59. Okay, one final thought is, with all of this information, don't forget that there is a Facebook group called Mr. Hudson's Homework Help. I will try to check that quite often during tomorrow as well as even today. So if there are some problems that you're having with anything here, feel free to get on there and post some questions. Others may even be able to help you on that, or I can get on there and help you as well. And if you have any question whatsoever, just use that Facebook page. Again, that is Mr. Hudson's Homework Help. Hope all's going well, stay warm, and when we have school again, get here safely, please. Bye-bye.